In this video, we're going to do a little bit of review about the concept of congruence of integers. It's the same notion of congruence that you saw in Math 210. Just wanted to give you a little refresher. So we're going to use a days of the week as a model for congruent integers modulo some number n. We'll give a formal definition of congruence and then show an example. So we're going to let n be a natural number and let a and b be integers. And the model we're going to use is if we have the statement a is congruent to b mod n, what that means is that a and b represent the exact same day of the week, not necessarily the same day, but the same day of the week when a week has n days. And to show you how that works in some examples, if we want to ask if 7 is congruent to 25 mod 9, well, 7 and 25 are 18 days away from one another, right? There's a difference of 18. And since there are 9 days in a week, that means 25 is exactly 2 weeks away from day 7. And so yes, 7 is congruent to 25 mod 9. And if we want to ask a similar question, is 12 congruent to 19 mod 4? Well, now we have 4 days in a week, but 12 and 19 are 7 days away from each other. 1 week is 4 days, 2 weeks is 8 days, because it's 4 days in a week. So 7 is somewhere between 1 and 2 weeks, not equal to one or the other, which means the answer is no. 12 is not congruent to 19 mod 4. So for our precise definition of what it means for A to be congruent to B mod n, well, let's see. So let's say that there are k weeks in between A and B, and k can be any whole number. If A is the bigger number, right, that means in order to get to A from B, you take A from B and then add the number of days in those k weeks. So if it's k weeks, n days in a week, that means there are kn days total. So that means B plus kn is going to give you A. So if you take B, add k weeks to it, that gives you A. That's exactly what that equation says. Now, if you wanted to flip it over and look at it from the other way, say solve for B, we get B equals A plus negative k times n as well. So both of those equations describe what it means to have k weeks between A and B. And on the flip side, if B is the bigger number, then same deal, right? So if we want to get from A to B, B is the bigger number, we take A, we add the number of days in those k weeks, that's kn, so we get B equals A plus kn. And again, if we wanted to solve for A in that, we get A equals B plus negative k times n. But there's a sort of a pattern in each case. I mean, whether or not A is the bigger number or B is the big number doesn't really matter. In each case, we have two things happening. A is equal to B plus an integer n. That integer is either k or negative k, depending on which situation we're in. And also, B is equal to A plus some integer times n, right? If k is an integer, if k is a whole number, negative k is also going to be an integer. So you get A plus integer times n equals B in both cases. And that sort of indicates what our definition of congruence is going to be, right? So if A, B, and n are in Z, the statement A is congruent to B mod n means, well, first of all, A is equal to B plus nk for some integer k. B is equal to A plus nk for some integer k. Now, those two equations aren't going to be the same k, but they are both going to be an integer. It's kind of maybe not obvious to see, but this is equivalent to n dividing A minus B. If you take that first equation and subtract B from both sides, you get A minus B equals nk. That is exactly what it means for n to divide evenly into A minus B. And similarly, if you take that second equation and subtract A from both sides, you can see that that's the same as saying that n divides evenly into B minus A. And then this one's maybe not obvious, but you might have to think about it. If you want to ask me about it, I'm happy to give you some insight into this. But it turns out if you divide A by n and look at the remainder, and if you divide B by n and get the same remainder, that's exactly what it means for A to be congruent to B mod n. Again, that's a little weird. And if you've ever heard of the mod operator, then what that's telling you is that A is congruent to B mod n means that A mod n is equal to B mod n. If you've never heard of the mod operator, then just ignore that parenthetical comment. See? Just like that. Okay. Woo, I'll skip right by it. All right, so again, this is a review. There is like one activity for you to practice, sort of like a proof that you'd see in Math 210 on the PDF file included with this video. I'm not planning on giving you a lot of time to work on it, but you should feel free to ask me questions about it if you have any issues, and I'll be glad to answer any questions about that.